Listen.
Hello, everyone. This is Data Driven Chat, and today I'm very happy to introduce Emmanuel Asimadi, who is a data scientist. He has a very cool blog that I really like. It's called Datanix, where he discusses citizen data science, like really some cool topics. He also has a kind of long journey in data science that I'm hoping he's going to share with us today. So hello, Emmanuel. It's great to have you with us today.
Yeah, hello, Ganna. It's such a pleasure to be with you today. And thank you for having me. Hello to your audience as well.
Thanks a lot. Thank you for finding the time. So a lot of people who listen to this podcast are actually aspiring data scientists. So for those people who are interested in getting into data science, can you share how did you become interested in data science? What was your personal journey into data science?
Yeah, that is an interesting journey. It's an interesting and a long journey for me as well. So I think my background as a person, I am analytical, and I sort of thrive more in the mathematical subjects than in other subjects. So if I would I have a science background precisely. So in high school, if you take the chemistry and the biology and the physics and the mathematics as a spectrum, I'm more towards the physics mathematics side of the spectrum. So it takes less effort for me to excel in those subjects. So that's what I have as a background. And then in terms of college, I did computer science and then telecommunication engineering. So it's a significant engineering background that I have. But aside education, I think one of the most important things that can happen to you in getting into a field of choice is getting the right opportunity. Okay, so you could have the skill set and possibly be able to demonstrate that skill set appropriately, but getting the right opportunity is also as important as having the right skill set for it. So for me, it has been a journey along the line of using my analytical skills and my interest in answering questions. So I find that I'm quite inquisitive when I have explanations. So I'm always trying to figure out why. And then there is that excitement you get when you are able to explain a phenomenon, especially when you have data that can explain it convincingly. There is that joy I also get when I'm able to explain it. So it's around my personality, one. And then the second point is around education. And the third is being able to connect to the right opportunity that will enable you to apply your talent.
So
and the third one is quite important. Yeah.
Yeah, so I want to pick a little bit on what you said. So you're saying, you need to get the right opportunity. So is it a combination of luck and skill when you get the right opportunity? So can you get it by having the right skills, or do you have to also get lucky sometimes?
Yeah. It's an interesting combination of luck and skill. But when you are skillful, your chances improve. Your luck is better. So it's that effort and consistency you need to be able to create that luck. Okay, so the difficulty we face in a field like data science that is rapidly changing is staying abreast with the trends. Okay, so keeping along with the trends that are coming up. It can be inundating, and when you start and you are not getting the outcomes that you expect, you're likely to stop. What keeps you going is to be able to keep going and stay consistent until the right opportunity comes.
Mm-hmm. So obviously, I mean, you worked on a number of cool projects. Some of them we can read on your blog. But if you had to pick one most important thing you have achieved during your career, what would that be? I mean, it could be a project or it could be just a career achievement, but you just have to pick one. That's one most important thing you're most proud of.
So I think I'll pick. I think I tend to value the achievements I had when I was naive and young. Okay, so it sort of gives you it feels more interesting and something big when you are young and you achieve. I mean, young in the sense that you are new in the field and you achieve something significant. Okay, so for me, it's been the time I spent in telecommunication at the Network Operation Center. Okay, so in telecom, you have a node that you call the Network Operation Center, where you collect all data around the telecommunication network and use that data to manage the performance of the telecom network. And that position is at the heart of the telecom network, so much so that if even a call drops on the network, you know about it. And it's a position where you are controlling so many resources and yet you are new. Okay, so you could be speaking to the CEO one day and just telling him that this is how the network is performing. Another time you could be speaking to a field engineer that is troubleshooting a very complex problem. And there are about 3 or 4 different teams troubleshooting that problem. And you are the only one who has the end-to-end view of the problem. Mm-hmm. And it's fascinating what you can do because you are the one who is the custodian of the data. Okay, so one team will typically say, we are troubleshooting this, and we think the problem is not in our domain, but the problem is actually in their domain. And you, by virtue of having the data, can prove to them that they actually have to sit up and fix the problem. And when you are cutting across experts as a data scientist, having enough understanding of the domain is also important in functioning. So you almost have to be a domain expert as well as a data expert to thrive. Okay, so for me, it is that role encompassing so many facets of my capability, being able to use data, being able to interact with people nicely, and then being expert in many fields. So whether it is the engineer troubleshooting in the field, being expert in understanding the business requirement of stuff. So that is the CEO or the marketing aspect of things, being able to understand what they mean by revenue assurance and all the different boxes that surround you is fairly interesting. And I think what makes you excited is the fact that people come to you as somebody who is an oracle, who understands everything about all things. Mm-hmm. And that is particularly intriguing.
Yeah, so again, I kind of want to go a little bit deeper into what you said. So you mentioned that it's very important to understand kind of the in a sense, a problem statement, right? Problem statement, like what is the organization is trying to achieve. Do you feel that it's always, the data science solution is always necessary when people approach you and they say, oh, we have this problem? Because from my personal perspective, very often I feel that people do not actually need data science. They might be able to achieve the same result or achieve what they want to do in the organization with other tools. So for me, the first question I ask, are you sure that's what you want to do? Are you sure you need artificial intelligence here? Is that something that you see a lot in your line of work, or is it like normally when people come to you, they really need a data science solution?
Yeah. So truly, that's a good one, and it's common as well. It plays out in different ways. So truly, there is the hype that exists everywhere, that everybody, even when they don't need it, want to formulate their problem in a way that is some advanced technology to solve the kind of problem they have. And then also the definition of data science for me encompasses more than just machine learning and artificial intelligence. So it spans from SQL all the way up. Mm-hmm. And it could include natural language processing, could include processing with graphs, where we deal with nodes and edges, and a lot of nuances in there. Now, when you pose a problem, it is up to the data scientist to use the minimum effort or the minimum tool to solve your problem. So when I use data science loosely to encompass those who are doing analysis and data analysis and stuff like that. So it's up to the analyst or the data scientist to try to solve the problem with the least effort. Mm-hmm. Okay, because you don't want to, you are given an equation, say add 1 and 2, and you try to differentiate to solve it. You probably could get an answer, but it is not worth the effort or the time that the business can afford to sort of to spend to solve the problem. So as a data scientist, you have to solve it in the shortest amount of time with the least effort, mm-hmm. because the effort can be something you pay for. So when you approach me with a problem, I would first decide that it is something we will need this tool or the second. So we would actually enter in an agile way, first with the easier solution and pick up the nuances around those outliers that we are not able to handle, and then go up with a second, more complicated solution, and then go to the third. So there's always the entry point that we get a first simple solution to get an understanding of the environment, and then we go further with the second layer, and possibly by the time we get to the third layer, we are happy with the solution we've gotten. Okay, so that would generally be my. What I also find is that people tend to downplay simple solutions. Okay, mm-hmm. So you have a case where the solution, finding an average of a variable is enough for you to take a decision, and the user doesn't want to find average. They want to find a moving average or a more sophisticated average, because the average is too simple a measure to solve the problem for you. So it is understanding that a great solution can be simple as well, and simple solutions tend to scale properly. Mm-hmm. So you should not downplay simple solutions.
So yeah, I mean, I think that's a great advice. That you need to look for, I guess, at a data science more broadly as kind of data analytics in general, and also, that if you can solve a problem in a simple way, that's probably a good thing rather than a bad thing.
That's actually the preferred way.
Can you tell us what are you currently working on? What keeps you awake at night? What makes you excited? I appreciate that you cannot tell us everything that you're doing, but if you could pick like one example of a project that you're currently doing, and
so that's good. Yeah, so I think what is keeping me happy at the moment, and I'm willing to share, is the datanix.ai mm-hmm. platform that I'm trying to create, where I want to build communities around the topic of data science and make it simple enough for everybody to consume. Mm-hmm. So my latest project is trying to convert the MOOCs, that's the massive open source courses, into instructor-led. So I take the course that Microsoft is offering for data science associates, for certification to data science associate. I take that learning path, and I'm trying to make it an instructor-led learning path. So just randomly taking the open courses and creating communities around them, so that we have a nice blend of free courses, as well as the classroom feel. You know, they can coexist. So we can try to do things like that, especially now that doing things online is becoming a norm. You could almost form a classroom around these courses and have people share knowledge among each other and then be challenging each other to do stuff. And I find that particularly interesting because it will be rewarding to see people now getting the mentorship they need in the field and getting that for free. Okay, because the field has so much information that if you don't get a bit of hand holding, you probably would traverse a couple of nodes and fall back. Right. Okay, so when you get some hand holding, you know which nodes to traverse to form the core of your knowledge, and then you can be adding the auxiliary knowledge as you go along.
So let's talk about
this platform is to do that.
So let's talk about these nodes. So as someone who's interested in practical data science especially, can you give some tips to people who want to start in the field? So where should they start? So you mentioned some online courses. Can you give people who are aspiring data scientists some recommendations? Where should they start? Maybe what languages should they learn? You know, what should they do? Like imagine that you completely nothing about the field, but you're very interested and you want to learn. So where should I start?
Yeah, that's very good. So there are a couple of areas, and you have to pick your profile that you want to build. Okay, so the profile is the profile of an analyst or a BI, business intelligence specialist. Is one side of the spectrum, and those are those who generally do the analysis and do the descriptive and the diagnostic aspect of things. Then as you move to the right side of the spectrum, you have the data scientist who is doing machine learning, modeling, doing more complex stuff with the data and has probably a couple of programming languages under their sleeve. Then you go to the data engineering aspect, who is the person who is actually putting things into production and making sure that things are scaling properly and then handling problems in production. So that is the spectrum, and you choose which profile best fits you. Okay. For me, I think the entry point of that spectrum is the profile of the analyst. But nothing stops you from entering as a data scientist or as a data engineer. Now, all the cloud providers have learning paths for these different profiles. And I would treat this as the syllabus or the curriculum for somebody who wants to do practical stuff. We also have to be quick in distinguishing advanced research from practice.
Right.
Now, if you don't have that distinction, you can end up running around a lot.
So can you, for those who do not understand what is advanced research and what is practice research, can you basically explain what is the difference?
Yeah. So in practice, we have models or we know are capable of solving problems in production. Okay. The role of somebody in practice is to take today's problem and map them onto existing solutions that we can take into production to solve a problem. Okay, so a decision tree works this way, and you know the variables, you know the configurations, and you know it is a model that works well in production. Then you are given a business problem. Yours is to map that business problem or transform the business problem into a problem that can be solved by the decision tree.
Right.
And you know that the decision tree will thrive in production. You don't have a problem with that. Okay. As a researcher, you are in a different sphere. You are bringing in new knowledge and almost like at the edge of knowledge. Okay. So what you bring out doesn't have to be production ready.
Right.
Okay. So you are sort of pushing the edge of what we can do as humans. So it doesn't necessarily have to be production ready. It can just be the thinking on what we can do to improve stuff. Okay, so that is different, and that is more advanced. A lot of the things you see in public can be in the category of research, where you think of them as things that are not ready for production. And if you are a student or somebody wanting to do things in production, going after those advanced knowledge is almost something that might not benefit you immediately.
Mm-hmm.
Okay, so you are better off focusing on the 80% that can go into production before bolting on top of that the advanced knowledge. Okay, so I can give a classical example of Google coming up with the chatbot called Mina recently.
Mm-hmm. Yes. Mm-hmm.
They would tout it as the best chatbot in the world. Okay, but that chatbot can never handle a conversation like an agent to the extent of resolving the problem of a customer. You can't use that chatbot in real life to handle customer complaints.
Mm-hmm.
Okay, so if you want to do something in production, you cannot use Mina. But Mina is a great progression of chatbots.
Mm-hmm.
Okay, what we can do is to use what is possible in production right now for chatbots. And that is almost like a glorified decision tree. Given the natural language A, use this part of the tree. Mm-hmm. Given another one B, use the second part of the tree. C, use another part of the tree. There is some level of intelligence in there, but it is quite plain, very straightforward. And those are the type of things you see in production. You get a job profile that is highlighting the skills of the likes of research and advanced staff. But what is in production is way below that. That's what we tend to find a lot. Okay, so you might advertise the job as if you'll be building the likes of Mina. But for every business to stay afloat, mm-hmm. they do things with specific rules. Because when you get too complex and unexplainable, humans don't like it. Yeah, so you can have a machine learning that is predicting right, but once we can't explain it, we will not be able to use it.
Right.
So those,
yeah.
Sorry.
No, it's okay. So I just wanted to kind of again expand on that, and I think also to your, I really like the distinctions that you provided, between roles and also between kind of the the sort of more fundamental research, or conceptual research, and practical research. Yeah. That's awesome. Mm-hmm. I also think, like, to add to your example, we probably could also say that a lot of things that are developed are not really future-proof. Like, again, taking the Google chatbots, I think one of the main kind of selling point of Google chatbots is that, humans cannot tell the difference, like, between the human and the chatbot. However, right, it's all a matter of training. Like, as humans, we don't have a lot of experience with talking to chatbot, but as we gain this experience, a few years down the line, we'll be able to tell the difference, and we probably will judge the business, the service quality by whether we are talking to a human or we're talking to a bot. I don't know about you, but, like, for example, I'm the kind of person that, when I call a bank or like any automated system, I will push whatever button there is to get to a human being. Like, I don't care. but I need to get like a human being on the other side. And if had I known that were a computer, I probably wouldn't treat this bank, or this service the same way. Whereas, like, for example, my sister, like, I have a sister who is 7 years younger than me. So she's quite eagerly, talking to machines. So I guess, different people have different tolerances, but don't you feel that, like, also we're not thinking too much, like, as people who develop, I mean, I develop also, things that are like very, very similar to chatbots, technology tech for chatbots. So do you think that we are not really thinking about the future and how this will be perceived like by people, rather than, concentrating on tech is one thing, but concentrating on customer perception of the tech is also a very important part of the job?
Yeah, that's true. That's true. So I think the evaluation, what you just said, almost questions the way of evaluating these services. Okay, so the test you mentioned is the Turing test, where the human is trying to determine whether the person behind the screen is a bot or an actual human being. And probably that test does not pass does not pass how we should be evaluating a chatbot, for example. So when you are chatting online, you are interested in the chatbot bringing an outcome that makes you happy. You are not trying to determine whether it is a human or it is not a human. So that mode of evaluation almost fails when you take the chatbot into production. Okay, so for me, it's one questioning what are we building the chatbot for, and designing evaluation that is specific to that, so that it almost like it can succeed when it goes into production. But and when we come back to the distinction of having staff that is research advanced, and then separating that from production, we tend to think along the lines that sometimes those of us in production almost always want to go for things that are the cutting edge. And that is a feeling we tend to have as well, that you are not satisfied with your solution until it is using deep learning, or until it is using the latest form of deep learning, like the BERTs and all that. And that is a shortcoming we tend to also have. So it is understanding that when the things that work are different from, I don't know if I have also addressed the specific question you raised as well.
Yeah, I think you did, and it's indeed. I think it kind of goes back to your earlier point about the problem statement, right? You need to make sure that you don't hurt the business ultimately by doing something. You could be too kind of tangled in this. It's a very kind of, it's a very sexy thing to do. To play with technology and come up with something cool. But then you might actually hurt the business by doing that, and that's something that should be always at the back of your mind when you're developing things. So the next thing I want to ask you is around again coming back to building a career in data science. In your opinion, what is the most important thing to remember if you want to work in data science? By that I mean, I would like you to maybe remember something. Oh, I wish I knew that before I started my journey in the data science. So so what is like this? Maybe one thing, or like a couple of things that are very important. Yeah.
So I think for me, what is most important in data science is the fact that you are serving others. Okay, and so you have to understand them well enough to be able to serve them correctly. So data science in itself is not the end; it is just the means. Okay, so you have the data, but somebody else has the knowledge on what to do with the data. You are supposed to almost be the enabler for the person. And the first step in enabling the person is understanding them well enough to be able to enable them. So that is something that is, sometimes we think is trivial, but it's not. Because when you are interacting with people provide information in very different ways. Okay, to somebody, when they want to criticize you or tell you something, they are actually criticizing you. Okay,
right. Mm-hmm.
they will tell you something so harsh that you will not have the capacity to process the feedback they are giving you. Mm-hmm. So you should have the personality or the coping mechanism to be able to process the information behind the criticism, right, no matter how harsh it is. That's one aspect. But the important thing is to know that you are an enabler, not the end in itself. So understanding the various domains and seeing how the data can power those domains is the most important thing. Okay, and it also involves knowing what you can do today and what you could be doing in future. So you sort of know the capability now and help the teams should they see certain types of problems in their domain, you could help them solve it.
Yeah, I think that's a great. I think that's a great point that you indeed you are basically connecting. You are connecting different parts of organization with what you do as a data scientist. And yeah, indeed, like in my personal experience, like a lot of times when people ask questions, they just want to make a statement, and part of the job is actually listening to what that statement is, right? So to hear what is it that this person is trying to say. Because very often, question is not a question, right? It's actually something they just want to get something off their chest. So you're trying to understand, okay, what is it that they want to say. So kind of expanding on that. So you already mentioned the data mix, and definitely, I think this is something that people who are listening to the podcast. This is a blog that people need to check out. It has a lot of cool examples of projects that you have done, and I just want to kind of interrogate you a little bit on the ability to code. So you mentioned that there are different roles that you can assume in data science, and you can be this kind of front-facing person who does business insights. But how important is the ability to code? So do you always need this ability? And if you do need it, like what do you start? Do you learn Python? Do you learn R? What do you learn? Or do you just learn algorithmic thinking? Like what would be your advice?
Yeah, so that's a very good one. So I think overarching skill you need is to be analytical and almost inquisitive. That is the topmost skill that is important. And then as you go along, you see that you are better at analyzing and questioning or information when you have tools under your belt. Okay, so one of those, I think the earliest one is being able to do SQL query structured data. That is the beginning of it. Mm-hmm. And there are a number of portals, and I will discuss the portals later. But SQL is one of the earliest languages you can learn to be able to work with data. And that is working with structured data. So data in tables, columns, and very nice rows. You don't have too much of a problem with that. And then if you think you are okay with SQL, you probably want to pick up a language because languages give you some kind of a functional, some additional function, okay, but they give you a functional paradigm that is not available, or scripting ability that is not available in SQL, so to say. So when you add a language like Python to your toolbox, there's almost like a new wave of things that you can do because you are able to program in a certain language. Now when you do that, you will now be also interested in the technologies that are in vogue now to be able to break into the workforce and do stuff. So technologies in big data, I can mention Apache Spark as one of the nice entry points for working in the field, because almost all job descriptions have that kind of requirement. And why Apache Spark is interesting is because within the same framework, you have it's almost like when you break it up, it's almost like the syllabus for data science. Within the framework of Apache Spark, you have the SQL, you have languages, so you have Scala and Python. I'll typically go with Python and then use Scala as well because they are similar. And then you have being able to deal with graphs. So that is data that is arranged in the form of nodes and vertices. So when you are in that framework and you are learning a framework like that, you are sure knowledge. And it is the core knowledge that you need to get off the ground. Okay, so you get the graphs, then you get the knowledge around machine learning. So that's around being able to do the machine learning stuff until you get into deep learning and stuff like that. And to just digress a bit, in production, it's not easy to build a model with deep learning. You need a lot of data.
Mm-hmm. Yes, of course.
To be able to do that currently. And yeah, you'll be better off using a service by one of the big guys, Google, Amazon, and the likes. Okay, so you can be sure that you'll be okay if you are learning machine learning and you know just the basic machine learning algorithms. Mm-hmm. And then over time, you can put on top of that the deep learning stuff. And then in Spark as well, you have the streaming package. Okay, so you see in the same framework, without leaving the environment of Spark, you know SQL, you know Python, you know machine learning, you know graph, and then you add the requirements around streaming data. So that is data that is flowing into your system continuously. Mm-hmm. By the time you finish that core curriculum, nobody can take you for granted.
That's right.
By knowing also, so it's being able to take that core knowledge mm-hmm. and then starting something with it. From then on, you can now specialize from time to time, do your specialization on top of that. And the portals that are available to you to learn some of these things are the open source courses that these cloud providers provide for you. So Google has its own open source, Amazon has it, and Microsoft, which is the one I'm trying to do in data, also has it. Then there is Kaggle Learn. So Kaggle in the past has been synonymous with competitions. Mm-hmm. And that is good in itself, but some people are not competitive and don't want to have anything to do with Kaggle because it is a competition portal. But now it is more than just a competition portal. You have Kaggle Learn, and you have all the different models from SQL down to programming in Python, down to dealing with BigQuery and machine learning algorithms. All those tutorials are available on Kaggle. Mm-hmm. And the good thing is that in Kaggle, you just need your browser. You don't need to install anything. You go there, you have the data, you have the technology all in your browser, and you can start learning. It has never been easier to learn it mm-hmm. than it is today.
Yeah, that's right.
And I'll just add.
Yeah, go ahead. Sorry.
Just add briefly that in the past, if you wanted to code or do something with Spark, for example, you needed to deploy the environment yourself. Mm-hmm. And that is the biggest blocker to learning any new technology. Okay, you install the environment and it's not working as the tutorial is telling you to do. And you have further problems. You drop off at a very early stage. But with new environments like Kaggle, there's Google Cloud Colab, even Microsoft Azure has their own Azure notebooks online, which are free to access. The problem of installing stuff is out of the way. You can focus on learning. Mm-hmm. And then when you know enough, you can now go to the details of it.
Yeah, so we on this podcast we had quite a few people who are like Kaggle grandmasters, and we had for example Abhishek Thakur, who I think won like 4 of these competitions. And then we had Dan Becker, who is basically leading the educational side of Kaggle. So yeah, there are. So yeah, I do agree. It's, to me it was a revelation, because like I was only exposed to kind of scientific part of the data science, and to discover these communities that and actually the high quality of learning and interactions that they provide is actually, it was quite a it was a big deal. Like I was like, wow, actually practitioners also get together just like we do at conferences. Like you guys also do stuff, and but I wanted to kind of a little bit maybe challenge you slightly there, and I think that when I was, for example, when I was way younger than now, like we used to have like Q Basic, or then we had the C, C++, C++, then we had Java, then we had, so now, currently we have Python, like we had R, like then we, currently we have Python, which is kind of the dominant language. Now I'm, for example, now learning Julia, and I don't know, like there are so many alternatives now that like, emerge. So, and it's, I think for someone who's trying to just start in data science, it's very difficult to make a choice. Like what, like, because it's you need a considerable time investment when you are learning coding. And of course, like I feel that it's all, if you're learning to think in algorithms rather than learn code in itself, it's probably helping you more. But that's my feeling. Do you think that that's right, or do you think that actually Python is a good investment? So would you say that Python is a good investment of time?
So which language is a good investment of time? For me, it's is the language that does the most amount of work for you. Okay, so you have to choose a language that can do majority of the work you need to do. And Python, with the community it has, and the people around it, and the packages around it, seems to be on top at the moment. So Python is among the best entry points you can have. Okay, and then from then on, you can be a polyglot where you know multiple languages. Okay, so the beauty of knowing multiple languages is that they all are implementing the same concepts, the same data structures, but they are doing it differently. Okay, so when you know Python and you know Scala, you know what to expect from Julia. You just don't know the syntax.
Right, exactly.
Okay, so
exactly.
So it's just a case of figuring out the syntax. And if Julia is not implementing it, it's a language that you don't want to be in because it's difficult to implement the basic structures. But by virtue of the fact that you know one or you know two languages, you know what to expect from other languages. Languages will have data structures, strings, maps, they will have dictionaries. Some call it list, others call it dictionary and stuff like that. The nuances are slightly different, but you will know what to expect from a new language. And you'll by then be able to establish that this language fits your philosophy than the other language. For me, it's the case that I think Java is verbose. Okay, so Java before Java 8 is verbose. That when you are working in data, you don't want to have to reason about the language you are using to program against data. The problem you have in the data space is complex enough for you to now have to worry about the syntax to program against the data. Okay, so the language Python is the closest language to natural language for you to program against data.
Okay.
Scala does a very good job as well in being very, it's more explicit and straightforward. You want to do a procedure that affects all the elements in a collection, and it's just about 2 lines or 2 dots. And you can process something that is affecting a whole collection. And so it's, for me, when I'm coding against data, I want to focus on the data and not the language and the languages for data might be different from the languages for software development. And it is okay for us to accept that.
Yeah. Right, exactly. Yeah, so I mean, so there you go. Here's the advice from Emmanuel. Learn Python. It's a good investment. It doesn't look like it's gonna go away, but definitely, I think it's good. I think it's just a good mind exercise to try to learn a different language, whatever it might be. And it's probably worthwhile. So we obviously cannot avoid.
But Ganna, just a quick one. If even Python goes away, the learnings you have, the investment you have made in Python are transferable to any other language.
Yeah, so
that's what it is.
I think I completely agree. So I think even like the knowledge I have of QBasic, even though I haven't written like anything in QBasic for a very, very long time, because it's ancient, right? It's still very useful. Like for example, if you know C++, right? Then if you do anything in MATLAB, for example. That's that's pretty much the same the same structure. So we obviously cannot avoid the subject of COVID, and coronavirus affected like various aspects of life. And I was wondering, in terms of the role of data science in helping solving the current crisis, do you think there is a place for data science? So will data science play an important role in this? Can it play an important role? And maybe if you could think of some applications where it might be particularly valuable. Because there are different opinions now, right? There are people who say, and there were people on this podcast who said, we shouldn't kind of, as data scientists, add to the bullshit because, we don't know anything about epidemiology. So if we do, if we do something, it should be like with epidemiologists, like you said, like serving those communities. And there were other people on this podcast who said, oh, totally, we can do so much and we should do a lot because data science is a powerful tool. So what on which on which side of the spectrum are you, or are you kind of the golden middle person who thinks that a little bit of both is the way to go?
So being a data scientist, I'll be biased towards the school of thought that says that data science has a role to play, and it might be a significant role at that. Okay, so the epidemiologist is a word that I always struggle to pronounce. The epidemiologist.
You pronounced it very well. Yeah.
They specialize in disease and using statistics to manage diseases. Okay, so they have that expertise there. I'll give a very classical example where there was this the decision on whether face masks are effective for controlling the spread of the disease or not. In the beginning, the advice or the guideline from the WHO was that face mask was not that necessary. It took one of these data scientists on Twitter, I've forgotten his name, he has the hashtag face mask for all, to use data to prove to a large extent that those who wear face masks have the disease under control. Okay, whether it is a spurious correlation or not, there is some indication that face masks influences how the disease spreads. Mm-hmm. We can't entirely explain whether it is by virtue of the face mask itself or the fact that when people see others wearing face masks, they tend to distance themselves properly. Okay, it could be any reason, but the fact that now we can use data and almost empirically show that face masks are important to controlling the spread of the disease is a clear example of what data science can do in this scenario. But for me, COVID is a pandemic at a time where technology is so advanced that we are inherently using data and data science technologies already. Mm-hmm. We almost every day every hour know how many people have it, what underlying conditions are playing out, what is the risk factors. We know all these things. These things overlap with epidemiology, but the data science is at the core of it.
Yeah, so
Okay.
let me just sorry again. I feel that I'm trying to challenge you the second time during the podcast.
Let's go for it.
But let me challenge you about this. So you know, I think and this is the point you made earlier in this podcast, that you know, as so like for example, when you're doing the projects within the organization, or you know, you're doing a research project where you see kind of end-to-end journey of the data, then you know where the data comes from, you know, how it was collected. You can make sure that the data quality is good, or at least you can clarify where it wasn't good. And, you know, I think with COVID even with COVID numbers, we have a big problem, right? Because we don't know, considering that there's such huge lack of testing materials, right? And it's like in the UK, basically, it's impossible to get tested unless you're a celebrity. I think. Like I personally tried. Like I thought that at one point my son was like, you know, exhibiting the symptoms. I couldn't get tested, and we couldn't test him. So I think there is like a lot of scope, and I mean, this is where data science also helps, you know, in trying to understand how many untested cases there are. But like my point is that the data that we have, you are absolutely right that, you know, we do have a lot of data, but I guess the quality of that data is not always bulletproof. So you know, and when we are making judgments based on that data, that is potentially, you know, that is potentially dangerous, isn't it?
If you look at the data in UK at the beginning of the strategy, at the beginning of the outbreak, they limited the access to hospitals. And so if you try to compare UK's data with the external other countries, you will see that you draw the conclusion wrongly that the fatality in UK is higher. But it is just because there is a selection bias that they are testing only the hospitals and not the entire population. Okay, but we can now understand the different trends, and some of them are explainable. So we can explain those away and then see that, okay, in Germany, the fatalities are lower because they are testing more. So it is a good idea to test more. So we can almost explain the differences and rule out the differences that are due to strategy of testing, that are due to spurring of capacity for testing. We can rule those out and still find value in the data. Okay? Right. If, for example, a country is having low fatality because they are not testing widely, I could first look at their data and say, oh, wow, this country is doing well. What are they doing right? And when I go further and I probe and I realize that no, it's because they are not testing widely, I've gone down a rabbit hole, but I took a chance. I could go in there and find that they are doing something right that I could bring on board my strategy. So it gives us the starting point.
Yeah. That's a fair point.
To sort of to find the countries that are doing things right that we can copy. That we can copy. And now to speak to your question around an interesting application of data science in COVID, I think the fact that we can use data to predict the trajectory of the disease and know how many cases we will get in future if nothing changes is one of the common use cases. Okay, so if you can predict in 2 weeks that a lot of people will get it, you have done something good. But if you're able to do that prediction and then you put in measures and you can see that because of your measures, you didn't get the same number of fatalities or the same number of new cases, you are now beginning to use your prediction to assess whether your measures are good enough or not. Okay? Then there is also the element of contact tracing, which is what we are going to use as an exit strategy of the disease.
Right.
Okay, so at the moment, there's no vaccine, and the only way we can get back to work is to get the spread as low as possible so that contact tracing becomes effective. Okay, now there are apps coming online to enable contact tracing. Contact tracing in itself is a very good graph problem, okay? So that we can arrange data in the form of nodes and edges, where one node can be a person and another node can be the medium in which they were in. Okay, so if I was in a conference with you and I was in close proximity with you at that conference, I am a node. The conference is a node that you and I share. Mm-hmm. Okay, if I take a bus with another person, I am one node and the bus is a node that I share with somebody else. Okay, so we can arrange that data in the form of a graph. When you do that, it becomes almost trivial to contact trace. Okay, so when assume that I get infected with COVID, the query to find other people who shared the same medium as me in the last 7 days or so is trivial with languages like Cypher in Neo4j. Okay, so I just say I'm interested in Emmanuel and I care about every medium he has been in. And then you take that medium as the second node and that I care about everybody who has been in that same medium. Mm-hmm. It's just 2 lines of code. Right, and I can extract everybody that Emmanuel is likely to have infected. Mm-hmm. And then trigger a message to them to self-isolate, or if they see symptoms, take it seriously.
Mm-hmm. Yeah.
So but that is just the highest level. There's more to that.
Yeah, we do actually quite a lot of work on this within Turing, and I do I do a project on this with colleagues from several universities, including universities in Nottingham and also UCL. So yeah, I mean there are but there are like many teams I think working on proximity apps right now.
Like that. Yeah.
So I want to kind of zoom out even at a grander scale and look at the future of data science. So what is the future of data science? How will it develop in the next 5 years, in your opinion? What are the hot topics?
Yeah, I think you probably know the hottest topic in the field. by a far margin, artificial intelligence, deep learning are the topics in the field. Mm-hmm. Whether they are actually in production as much as we see them in the media is a different one. In that field of artificial intelligence, the future is how we overcome the shortcomings of deep learning. Mm-hmm. Okay, the shortcomings of deep learning specifically is the fact that we require too much data, or a lot of data to train our models. Okay, that is the shortcoming, and the fact that it doesn't take into account common sense. Okay, so to be able to do something that a human will do with common sense, you probably need volumes of data to train a machine learning model to do that. Mm-hmm. So that is an interesting problem we have to overcome going forward. So people think that, and I generally fall in that school of thought where there is the element of adding the symbolic reasoning to the progress we have made in the area of learning in artificial intelligence. So when you take artificial intelligence, it has a number of branches. You have the reasoning aspect and the ability to learn as part of artificial intelligence. We can consider that we have progressed significantly in the ability to learn using deep learning, but we are not able to use those same approaches for reasoning. Being able to reason is part of intelligence, okay? And the elements of what we call semantic web, symbolic reasoning fall in the area where you can lay out data in a way that machines can reason about it,
right? Mm-hmm.
Without having to be trained on it. So you say United Kingdom is part of Europe. And when you ask the question, tell me the countries that are in Europe, the machine is able to bring up United Kingdom. So if you are able to put out the data in a way that is laid out nicely, the machine will be able to reason around it. Mm-hmm. It is being able to put in the reasoning capability that will be really transformative to artificial intelligence. Mm-hmm. Okay, so that is one area that will be interesting for us in data science. There are other elements. You have a question?
Yes, yeah. So, I think that's. I think you mentioned quite a big chunk of work that we yet have to do in data science. But also, I was wondering, like in terms of progression of data science in business, I think. We all realize that data science has a big potential in business, right? But how do you think? Do you think this potential will actually realize in the next 5 years, or this is going to be like an ongoing process of discovering what data science is capable of and maybe understanding how it can change various industries? So like from like you talked mostly from kind of modeling perspective, but I just also want to ask you like on a soft side, what can we expect?
Yeah, so on the business side, we can expect a lot, and I think data is actually transforming a lot of businesses that use it. And when I speak data, let's not think that data science is that advanced machine learning stuff. If you can set up your organization in a way that it continuously derives value from your data, you are doing it right. Whether you are using machine learning or whether you are using SQL or whatever you are doing, once you can derive value from your data, it's good. A typical example is Amazon. And you see how Amazon uses its data to derive value. Mm-hmm. And then you know how an organization should be set up to use data. So you can set up a business like Amazon today, and if you don't have the data and the recommender algorithms that they have, you can't compete with them. And they are differentiating just based on data.
Right. Mm-hmm.
Okay. So by virtue of their data alone and the fact that they don't just store the data as a cost, they actually use the data. That process of storing and using the data in itself is a differentiator. Mm-hmm. And that is a viewpoint that businesses should have. Mm-hmm. That when I have data, I can actually use it as a differentiator. And the worst case is that the least you can do is to provide anonymized data set that other businesses can use to inform their decisions. Mm-hmm. And in that way, you are already selling your data if it is allowed. And I think you have to obey the ethics and stuff like that. But for businesses, they would derive big value from data if they want to. And that value would come from them using their existing data sources properly or from connecting other data sources to their internal data sources. Mm-hmm. Okay, so by using your data sources right, integrating to other data sources is another one. And then the speed of decision is another thing you can influence. So if today you are generating a report that you generate weekly, you should start asking yourself, why can't you generate this report daily? When you are on daily, you should start asking yourself, why is this report not streaming? If you are streaming it, you should now ask yourself, why can't the decision be automated so that when the flow has an anomaly, it sends an email to somebody to act. So that person doesn't need to be monitoring the report or the stream. They will get an automated message of an anomaly that they can respond to. Mm-hmm. Okay, so whichever part of the spectrum you are, you have the capability of climbing. Okay, so it's just like my favorite Martin Luther saying, if you cannot run, walk. If you cannot walk, you should crawl and stuff like that. Mm-hmm. There's always the ability to go higher and higher and higher and derive value. It's up to you to understand the key points that I mentioned earlier. And for businesses and for the data science profession as a whole, I think what could be interesting is the level of automation we can achieve. Okay, those I'll call the extremists think that we can automate data science out of the loop.
Thank you so much, Emmanuel. I think you just basically explained how data science propagates through supply chain, which is kind of very important, very important understanding, I think. And many organizations do not think about data science in that way. And hopefully, in the next 5 years, we will get to this realization. No, maybe if not at the global scale, but there will be some level of maturity in organizations to understand that data science can actually change the entire supply chain. So we are kind of almost at the end of the podcast, and this is a traditional question that I ask at the end.
Oh yeah, right.
And many people complain about it. But the question goes like this. So if I asked you to recommend one book and one film, what would be your recommendations? And they don't have to be data science books of film, so they don't have to be directly related to data science, but something that really inspires you and maybe made an impression on you.
Yeah. So you insist on one. That's that's it, right?
I do.
So if you insist on one, and because this session has been about data science, I will take a different book, which is not related to data science, which is Gary Kasparov's book on how life imitates chess.
Yeah, that's an excellent book.
So he sort of tries to model life and strategy of playing chess together. Okay, so and we can learn a lot from how chess players do stuff and almost transfer that learning into real life. So that one is interesting for me. And I think I like the things that speak to strategy a lot. So I think that's why I like that book, because strategy is the game changer when you are in operations or when you are in real life. So it's not about doing a lot of work. It's about doing what is effective. Okay, so you do the most effective thing, get yourself leverage to be able to cope with new things that will come in the future. So I like that stuff around strategy. And then when we come to movie, I usually don't watch movies myself. I tend to follow recommendations from others.
Right.
And I chanced on this one. And it's not a 2-hour movie, it's a whole series. That's the Game of Thrones.
Okay.
So it's something I love because he had so much strategy, especially the first 6 this series. They had a lot of strategy, a lot of thinking and maneuvering human environment. And they pose a lot of ethical dilemmas that you need to solve. And sometimes you are happy, bad things happen, but sometimes you just face problems, tend to put yourself in the nature of that character and decide what you would have done. And it's fascinating because you also want to be moral as well as, you want to be ethical, but you want to survive the wickedness around you. That's the way I saw the Game of Thrones. So I like that because it had strategy, it had a human behavior understanding in it.
Okay, so great recommendations.
I hope that answers it.
Yeah, great recommendations. Thank you so much, Emmanuel. And for those of you who haven't watched Game of Thrones, you need a lot of time and a lot of popcorn and a lot of drinks, maybe, to get through all the parts. But yeah, it's a nice series. So Emmanuel, thank you so much for finding the time to talk to me today. You shared a lot of really cool ideas and your experience. And I'm sure many people will appreciate that. So thank you so much for doing this.
Thank you, Ganna, for having me, and thank you to your audience as well. I hope sometime we'll connect again.
Thank you.